whereas a class is sort of a template for some entity, whereas an object is a specific member of that entity. You know, we could talk about book as being a class. Let's say we were doing a library system. We could talk about a book being a class, and then a specific book of head first Java would be an object. You know, the analogy goes. And we talked about classes having attributes and methods, properties and functions, a lot of different ways to say it. Behavior, sometimes another word for methods. The idea is that they have characteristics. A book would, for example, have a number of pages associated with it. A book would have an author or authors. A book would have a publisher. A book would have, like, the type of book it is, whether it's a hardcover or paperback or whatever. Then in addition, especially within the context of a library system, a book could exhibit certain behaviors. You know, a book could be purchased. A book could be taken out. A book can be returned. And so on down the line. We said we were going to start out with a pretty simple example, and I've been debating a little bit how to cover this exactly, because you know you really try to think about what the best way to discuss these things. And I think the best way to discuss this, rather than going for a perfect class in one shot, we're going to follow my own advice and do a bit at a time. We're going to jump into it. We're going to create a class for the particular entity that I want to model. And then we'll set about improving it instead of going all in one shot. All right, I think that'll make sense. And the class that we talked about last time would be a class that represented a picture, you know, a physical picture that you could put iced tea in. Again, it's hard to come up with examples that are not trivial, but then again, not overly complicated either. So this is the one I decided to go with. So, we said that the picture, here are some facts about the picture. Picture has a size in ounces. A picture has a number of servings associated with it. And we said that there's 8 ounces per serving. And a pitcher, in addition, has how many scoops of the iced tea mix it takes. And we said that was 16 ounces, 1 scoop. Okay. So, one thing that we might debate is what we're going to make attributes, what we're going to make methods. All right? And we're going to defer that debate for a little bit, and I'm just going to jump in and make a decision. I'm going to pick as an attribute the size. Why do I pick that as an attribute? Well, I pick that as an attribute because that seems to be the one aspect about a picture that seems to be constant, right? I mean, a picture is of a certain size. Servings, it could be that we decide to make bigger servings, in which case that rule would change. Or we could use a different brand of iced tea mix, whereas the number of scoops would change. But something that's 16 ounces is going to be 16 ounces, or something that's 64 ounces is going to stay 64 ounces. The pictures aren't going to get bigger and smaller. So that seems to me to be the most persistent one. Another way to say it is that seems to be the one that's truly a characteristic of the picture. The other you could call derived attributes. In other words, if you know the capacity of it, the volume of the pitcher, you can tell how many servings are in it following the formula. If you know the capacity, you can determine. So the other ones can be derived by it. We could conceivably make more than one an attribute. The difficulty with that is there could be inconsistency. You know, we'll get more into that later. This is a whole kind of thing that I wanted to avoid talking about right at the beginning until we actually got down and defined it. So what I'll do is we'll define a class for the picture, and we'll make, this an attribute, and these other two things methods. Now keep in mind, those of you that maybe read ahead or have some other programming experience or whatever, we're not shooting to do this perfect in the first pass. So I'm gonna change some things between the first pass and the second pass. All right. So let's go and let's make our class. So I will go into Notepad. And I'll get rid of all these classes for now. Or first make a shortcut of them and then get rid of them. Oh, it's not on the screen. Good. All right. And now I'll go in here, and I will make this a public class. Public class picture. I'm making it public because I want other classes to be able to use this class. All right? We're developing components, and for the most part, classes like this are going to be public because we want other classes to be able to access them. So we'll make a public class. All right? I'm then going to define the attributes. And this is the one thing that I'm definitely going to change. So this being pass 1, I will change this in pass 2. I'm going to make a double volume in ounces. That's my attribute. All right? Any more is getting to be, I can tell what day of the week it is, whether I'm thinking in Java or thinking in Visual Basic syntax. So it must be Monday, so I'm thinking in Java. If I ever do it in the other syntax, please someone remind me. And do keep in mind that I will be doing that on purpose to test to see if you're paying attention. All right. So now we're going to have, so we have an attribute, dim, or a double, dim, double volume in ounces, and I'm going to create a function to return how many servings. All right? So I'm going to make it public because, again, I want other classes to be able to call this function. And it will also return a double. And my function will be calculate servings. And I'm not going to pass any arguments to it. All right. Again, this indicates that this is a public function as opposed to a private. Double indicates that we'll return a double. All right. And calculate servings is the name of the function. There are no arguments for this. And what is this function going to look like? I'm going to just declare a double for the results. And results equals volume in ounces divided by 8. And then I'm going to return results. Okay? And I'll do the same thing for calculate scoops. Volume in ounces divided by 16. All right. And this is our first pass at this class. It has the attribute, which is the volume in ounces, which I declared to be a double. It has a method to calculate the servings based on the attribute. And it has a method to calculate the scoops based on that attribute. All right. Now we need to test this class. And one thing I want to stress in this class is proper testing. All right. Again, as I said before, even experienced developers, I don't think necessarily do a great job testing their software. This is a class. This is a component. I want to test this component to make sure it works and make sure it does the job that it was supposed to do. So what I'm effectively going to do is I'm going to write a little test routine. All right? And that test routine is going to be my Java class. It has a main in it. It will create objects of this type. It will set some attributes, call some methods, and I'll look at the results. Ideally, that test object I could keep around, so if I later made some changes to it, I could run it through and retest it and make sure it was okay. That's sort of known as unit testing. I'm testing one little piece of this. All right, I'm testing the one picture class. If I had a whole application for my catering business that had pictures and had a GUI for trying to figure out how much to bring to a particular catering job, and I had this, that, and the other, that would be system testing, where I'm bringing all the components together and testing them. But now I simply want a little routine that's going to test this component. And really that's what your labs are going to consist with over the next while anyhow, until we get into GUIs later on, is you will have your, for lack of a better word, business class, business logic class, or problem domain class. And then you'll have a test class to run it through, and maybe some other classes, some tests. So I'm going to go through, and I'm going to save this as picture.java. Now, a couple of things. Again, that name should match the name of the class. By convention, the class name is capitalized. All right. I'm going to go and save that. Now I'm going to go save as, just because I'm lazy, picture test class. And this will be my class to test. And this will be like the kind of classes that we've done before. This will be sort of like the main line, right? This will be the boss class that's kind of running the show, and it's going to create these other objects and call methods on them. So I'm going to go public static void main. The arguments for this will be string And now we want to test our class. So how are we going to test our class? Well, one way to do it is, I know at home that a 3-quart pitcher, well, 3 quarts is what, 96 ounces, right? Is that right? I know a 96 ounces pitcher, or a 3 quarts pitcher, takes 6 scoops, all right? And it has approximately 12 servings in it. Okay, so let's test that. So, I can even go and I can make a comment here if I want to, / test for a 64 ounce pitcher. So, I'm now going to declare a variable to contain my object reference. This will sort of be, for the most part, although strings are objects, this will be the first real object reference that we're creating. And the way you refer to an object is you can say public p, and that will declare a variable called p that we can put a reference to a pitcher object in. All right. This is something that you don't have to do with primitives. Primitives being simple things. You don't have to go and actually create a new instance of it. The first line simply declares a variable for P that we're going to store a reference to a picture. The second line, P equals new picture, actually creates that picture object and stores the reference to it in P. Now, in a couple classes, we'll define very precisely what we mean by a reference to an object and storing the reference and all the implications of that. But for now, know that to really create an object, you need to do those two steps. Now, one thing that you can do, sort of as a shorthand, is you can combine those steps. Like this. Public P equals new picture. That declares my variable, says it's going to contain a picture, and by the way, creates a picture and stores a reference in the variable P. Now, I shudder to do this because this is not good programming practices, but we'll talk about why it is, and we'll talk about what to do instead in a minute here. I'm going to set the value for that size attribute. And what was that called? Volume in ounces. P dot volume in ounces equals 64. Servings will equal P dot calculate servings Now let's review what this does, and then we'll compile it and make sure that it works. All right, so here's our test class. When we run this, it's going to fire off the main method. What's the main method going to do? It's first going to create a test object called P, which should say picture, not public. It's my first typo. I apologize. So now we have a picture. We've created a picture in our application. We have to set its capacity. So we can say this picture, I'm setting the capacity, the volume in ounces, to 64. And then after I do that, I can call those two methods to display the servings and the scoops. All right? Let's make sure we saved everything, and then let's go and compile. I'm going to compile the picture test class. The picture test class, the compiling process will be smart enough to know that I also have to compile the picture class as well. So it will compile both of them. All right, it's thinking about it. All right. Not bad. That's actually more errors or less errors than I thought I had. The reason for that is these two are methods, right? So I need the parentheses. Without that, it thought that that was an attribute, and therefore gave me an error, and it didn't see the attribute. All right, there, it compiled cleanly. Wow, that's not bad. I was expecting a lot more typos. All right. So now I go and run this, and it will tell me that there are 8 servings in my 96-ounce pitcher. All right. And, or actually, I made it a 64-ounce pitcher. There's 8 servings in my 64-ounce pitcher, right, because 8 ounces apiece. And 16 ounce per scoop, it requires 4 scoops. So now I have that. Now I could go through all sorts of permutations of testing it and you know, run it with other numbers and make sure those numbers are correct. Depending on the complexity of the class, your test cases will either be more or less. All right? This is a very straightforward one insofar as there are no if statements at all in any of the methods. So there's no conditions I really have to make. Really, any if statement that you see in a test class, or I'm sorry, that you see in a method that you're testing, really constitutes, you know, a fork in the road. That's an additional test class. And if there's ifs under that, there's more and more and more. You know. So for example, your assignment for this week where you're testing the triangles. Think of the if statements you have, and there should be a test case on both sides of that if statement. Now, what don't you like? Anyone have an idea why I said I don't like the way this is coded? What issues do you suppose I have? Go ahead. It's hard-coded. That's one thing I could do better. I could actually define, eventually I could define a constant for serving size and number, you know, how big a scoop is. So that's one thing that I could do. My test case, I don't mind the fact that that is hard-coded, right? Because this isn't like real code that's going to be in part of my application. This is just code I'm writing to test my class. Later on, this might be hooked to a GUI where I go and say, okay, let me figure out how many pitchers I need. I think I need about 80 servings of iced tea, all right? And my pitchers are 64 ounces. Well, how many of them do I need? And then I might have a GUI that actually calls the methods and gives me an answer there, all right, based on numbers that I entered in. So the test is, it's okay that the test is hard-coded. This I could probably do a better job by putting these things as constants. We might talk about that today, we might not. We definitely will talk about that at some point in there. There's actually a bigger issue. Yes? Yeah, I have this as a public variable. I don't say anything, so it is an implied public, which means I can do this. I can go in and I can set that. I can set an attribute inside my class, inside my pitcher class. I can set it from outside the class. Now, what's wrong with that? Let me try to give you an analogy here of what's wrong with that. All right. If we look on a computer, you know, back here, all right, this monitor here has to get wired to the graphics card, right, for it to work. Hey, I'm at the edge of my hardware knowledge here, so bear with me, all right? That monitor has to be connected somehow to the graphics card on the motherboard, right? So what does that mean if I go and got a new monitor? Let's say this one blew and we brought a new monitor in. Would I have to go and open up the back of the monitor and hook up the wires inside there, and then open up the computer and find the motherboard and wire all the things in there? Would I have to do that? No. Why is that not a bad idea? Well, why is that a bad idea? Why is that not a good idea? Yes? Yeah. It's real easy to mess up, right? And messing up would have bad consequences. All right? So, the point of this is what do the developers of these hardware components do? These developers of hardware components give you these nice little plugs. You could call them interfaces, if you will. that as long as it has the right kind of jack, you can plug it in. So you have your USB thumb drive. You don't have to go and somehow wire it to the motherboard, right? You find a USB jack, it fits in there, boom, you're ready to go. All right? They've given you a method of accessing something on the inside in a very controlled, safe manner that you're not going to run the risk of messing anything up. All right? So that's what we do with hardware. We want to do the same thing with software, because if I can do this, if I can get right in and manipulate these attributes directly from outside the class, I could do something like this. Volume of that pitcher is negative 64 ounces. All right? That's obviously absurd, right? But you know what? I can go, because this class has exposed its innards to me, it's exposed its guts to me, I can go in and do that because it allowed it open. Yes?
Unless you had a hole in the picture and kept going down.
Okay, that's true. Even then, it probably would have a capacity of 0, and it would depend exactly where the hole was. But at any rate, and I can go and run this, and I can come up with, absurd results. I probably forgot to save it. All right. That to fill this, I need to put 4 scoops back in my jar of iced tea, and so on and so forth. All right. So by being able to access the attributes directly, I can do things that are clearly wrong. All right. Later on in this course, we'll learn how we can put validation code in there. All right. And we can put validation code right in our class so that no one can violate the logic rules, the validation rules for that particular attribute. All right. So what's the bottom line? We're going to hide those variables. We're going to hide those attributes, much like the designer of hardware hides the innards of the hardware. And we're going to give the user, in this case the user isn't a person, but the user are other classes that use this class. We're going to give the user nice little interfaces, nice little predefined methods to get to the things that we want to allow the user to be able to manipulate. So, what does that mean? That means that all our attributes are going to be private. Well, now watch what happens if we try to run this. We go and save this. We go to compile it. We got an error. It's telling me that I can't access volume in ounces from outside of the class. That's what private means. But yet we still have to create it. When we create our picture, we have to say how big the picture is. Well, we're going to give it a method. All right? We're going to give a method to give a value to that attribute. We're going to give a method to access the value of that attribute. And typically, the method to set the value is called a set method, and the method to return the value is called a get method. So I'm going to make a couple of public methods. I'm going to set the volume in ounces. And I'm going to give an argument to this guy that's going to be a double. And I'm going to set this volume in ounces equal to whatever the argument is passed to me. I'm then going to give a get method that is going to sort of do the opposite. It's not going to accept any arguments. It's going to return a double. and it will return that attribute. So, I have two sets, thank you. So, that volume in ounces variable is accessible throughout this class. That's what private means. Private means it can be still accessed within the class, right? It's an attribute of this class. This class has to know how to access it. All right, so I can set it, I can return it within this class. But no one from the outside world can access that attribute directly. They have to go through the method. And again, in my mind, the analogy is you're not going to take your monitor or your USB drive and wire it directly to the motherboard. You're going to go through the method that a predefined method or a predefined interface or a predefined connector that's going to bring those two together. So now what we'll do is we'll change this, and instead of setting it this way, we can say p dot set volume in ounces, and we can give it the value of 64. And now I can run it or compile it. Public void set volume in ounces. I think it's having trouble converting that 64 to a double. I do this one. Google this real quick. Yeah. So I should be able to go here and say 64.0D. That indicates a double of 64. And let's see. In ounces. Provided, of course, I remember to save the other class as well. All right. Then when we run it, again, we're back in business and it's working. Yeah, it probably did the implicit conversion for me. If I go and remove that, it probably is smart enough to do the conversion for me. Yeah, sure enough, it did. I was misreading the error message, thinking that it did not see that as being a double, and therefore changing it. But I didn't save the. I changed the picture class to add that method, but I never saved the picture class. Okay. Now, this is a small point, but I'm going to go in and I'm going to change all these to, instead of calculate, I'm going to change these to gets. And this, I suppose, is my quirk. The principle that we're talking about here, which is a key one in object-oriented development, is what's called data hiding. Data hiding, in essence, says that all the attributes of a class are private or protected. The difference between private and protected is relevant when you have subclasses, so when you have a class inheriting from that. So for now, we're really dealing with just public and private. When we start dealing with inheritance, we'll have protected in there as well. But we're going to make the attributes private. That means that no one from the outside world can get in and mess with them. Why not? Again, for the same sort of reasons, for the same analogous reasons as we can't go in and wire our things that way. We don't want anyone messing around with the inside. In fact, we don't even want people to know what's going on inside of our class. All right? We actually could put different set methods on here so that the outside world wouldn't be able to tell what was an attribute and what was being calculated. For example, let's say if I know the ounces, I can call a set method to set it directly. What if I know how many servings I want it to be? I want to have a 12-serving pitcher. How many ounces could it be? Well, I could still keep my same class. I could have a set servings method. Even though there's no attribute of set serving of servings. And what I could do is I could do the conversion to say, okay, take how many servings I want and figure out the number of ounces I would need to do it. So in this case, if I wanted 12 servings, would be 12 times 8 or 96. So I could say volume in ounces equals arg times 8. So in this case, you see, I'm storing. If you want to talk about storing or you want to talk about the attribute, the only characteristic I have about this is the volume. But to the outside world, I can plug in whatever I know, all right, and it works seamlessly. So I could go and do this. I could make another test and test for a 12-serving pitcher. Set servings equals 12. And then I could say ounces get volume in ounces. All right, let's make sure everything's saved. Yeah, thank you. Indeed it does. You're a good crowd. You usually, maybe by the end of the semester, you guys will like notice that and not say anything, and you'll snicker and wait for it to blow up in my face. All right, the first picture is 8 servings, 4 scoops, 64 ounces. Another one is 12, 6, and 96. My point of this is if you look at this code, we have no idea what that class is storing as an attribute, right? We don't know anything about the guts of that, the internal. We only know the methods that it gave us, that we're giving it. That's the way that we access this. So I could create the picture and set the servings and ask for how many ounces it is. I could say, gee, I have 3 scoops of iced tea mix left. How big of a pitcher can I make? I can do any of those things in any way I want to, regardless of the fact of what's an attribute and what's not. Okay? So that's known as data hiding. All right? The fact that the outside world doesn't have any access to, doesn't know anything about the internals of that class. Another key word here is encapsulation. And what encapsulation relates to is both the notion of data hiding and the notion that anything I ever want to put in about a picture, I will put in this picture class. So if there was, like, say, a different set of methods relating to making lemonade, let's say, instead of iced tea, they'd be in this class too. I'd be able to get at them through this class. Any questions about any of this? So, the bottom line is all our attributes, well, all of our instance variables, this is an instance variable. And what do I mean by an instance variable? I mean an attribute that is not a static attribute. Even those we probably want to, but should be private. Our methods are going to be a mix of public and private. Public methods are methods that we want the outside world to be able to access. Private methods are methods that we don't want the outside world to be able to access. Let's say, for example, we had a payroll calculation. And a payroll calculation might have a set of steps of intermediary calculations. All right? There might be one of those intermediary calculations that really is needed to do the rest of the payroll calculation, but there's no need for anyone else to call it. It's only used as part of the process of calculating the payroll, in which case you could make that a private method. All right? And we will access all the attributes through get and set methods. And whether they be actual attributes or derived attributes. All right? They will be accessed this way. Now, I'm going to jump a little ahead of myself because we can improve this class a little bit by saying serving size and scoop size, actually, it would be best if we made those like a constant in VB or in other languages. So, I could say private static final double serving size equals 8. We'll go over this more in the future, but since someone made the observation, I thought it would be good to put this in.
Private or public?
I want that to be private. I think I said private, but I copied the code from that page, so it came out as public. is an attribute. This is a case of an attribute that we possibly could make public because they can't change the value of it anyhow. All right. I would still probably argue that it would be best to access this, have a get method to get serving size or something like that. Get scoop size. And then we can go and change it here. All right, let's go and test this. All right. In creating my test class, by the way, I can do neat things like putting in like just a line of dashes between them. Like I can say this. And I can identify the test case. Now, if I wanted to thoroughly test this, I might test it for a pitcher of a certain number of ounces, a pitcher of a certain number of servings, and a pitcher of a certain number of scoops. That way I would have tested all the possible paths to this. So now that sort of makes the output a little more clear and all that. Now the idea with this is we can keep this test class, and if something changes and we make revisions to the pitcher, we can run it through the same set of tests, and we can add additional test cases and so on. All right, so it's good to have a little testing thing that's done in a systematic way as opposed to sort of a haphazard, I'll try this, I'll try that, and see if anything blows up. Now to summarize about this, classes have attributes and methods being synonymous with function or behaviors, attributes being characteristics or instance variables. We're going to make the instance variables or attributes always private. Later on when we learn like error processing, we could put some checks, for example, in the set volume by ounces that would verify that the size was a legal size, that the size was above 0 and smaller than whatever the Guinness Book of Records says the world's largest pitcher is or whatever. I don't know. All right. And the good thing is that no application, no other class could circumvent that, right? Because they can't get to the attribute directly. They have to go through the method that I've provided, and therefore whatever validation I put there, any class that tries to use a pitcher is subject to the constraints of that validation. All right? My methods, again, are going to be a mix of public and private, probably for the most part public, but I could have some private if it was like an intermediary calculation that I did not want to expose to the rest of the world. They often use that terminology of exposing a method. In other words, making it public so other classes can use it. My test class, again, is simply going to have a main, and it's going to create various scenarios involving my actual problem domain class. It will declare a variable, instantiate that variable, that is create a new pitcher, and then call the appropriate methods and output the appropriate values for that. All right. Questions? Notice that, again, there's a method to say calculate servings. I'm not having in my test code to look at the capacity and divide by 8, right, to calculate the servings. That would be a violation of encapsulation. And knowledge about a pitcher then would be Some in the picture class, some in the test class. Yes? Ah. Well, that would be a problem, wouldn't it? That would drive someone crazy at some point. All right. Other questions? Okay. I'm going to go zip this up and save it up to Angel. Then I'll be up to open the room. So I'll be up in the lab in a couple minutes.